ladies and gentlemen, welcome to the Institute for Astronomy. I'm Dr. Strong. I'm the Maui Technology Education Specialist. And one of the things I do is I go around twisting arms to get people to give talks here for you and for the internet and for our archive. And this month I actually didn't have to twist very hard because Svetlana is absolutely fantastic. So Dr. Svetlana Berdyugina, did I say it right? Hey, I actually got it right. So I still have my mistake or five to make, right? So Svetlana Berdyugina, she's a professor at the University of Freiburg, and she's a visiting researcher here at the Institute for Astronomy. We're very lucky to have her here. She is an expert on the sun, stars, planets, exoplanets, and also for searching for extraterrestrial life. And what's really great about her is I'll wander into the lab and I'll look over and there will be some crazy thing going on, and you'll sit and listen to her explain why she's doing it, and you'll realize it's just brilliance. And it's very inspiring. And so, like I said, we're very lucky to have her, and I hope that you enjoy the talk, and let's give her a nice Maui welcome.
Kiitos paljon. Hyvää iltaa. Добрый вечер. Guten Abend. And good evening, of course. So don't be scared. We will speak today many different languages. And since I am in your land, I speak your language, English. And when you come to my land, please speak a little bit my language. Whatever it is, those all four, you know. All right. They got it. Excellent. All right, so today we hopefully will learn something how to communicate with aliens. And aliens, it's a broad, let's say, subject, yeah? So I'm alien to you, animals alien to us, maybe in some sense, and those which are in space somewhere, they're also aliens. So we talk about all these aliens. And my talk will be divided in three parts, basically. So I start from a short overview of searching and also communicating with extraterrestrial civilizations. And these are abbreviations like SETI and SETI sounds the same, but first SETI is search and the second SETI is communication with extraterrestrial intelligence. And we already have done both, and bad news, we have found nothing yet. Yeah? But that is interesting to look what we already have done and what will be a possible response to our actions. Yeah. Then second part, we will look at the Earth life communications and try to understand that whether in our actions in our attempts to communicate and to search for extraterrestrial intelligence, something is missing, because we do not know completely what is the communication with aliens. We can look at our other life forms on Earth to learn about it. And then in the end, we try to describe some alien communications. And all right. You cannot hear in the back? Oh, I'm so sorry. All right, I try to yell. All right, so in the end, we look at alien scenarios, alien communication scenarios, and I will bring only three. The subject is absolutely broad, and I cannot cover everything. Does it sound better now? All right. Okay, so let's go first. SETI is search for extraterrestrial intelligence, and first attempts were to search is to detect special radio signals. What does it mean special? We're not quite sure. What we do is that we search for signals in radio range of frequencies where we have less noise and less weaker background from other sources. So the major sources of radio signals coming from the galaxy, from surrounding space, what we have from cosmic rays, and this is like this intergalactic or galactic radiation, and then we have also contribution from the atmosphere under which we are living. So these are molecules and atoms in the atmosphere. They produce also radio signals. So then we see this, like there is a kind of sweet spot in radio frequencies where the background is low and where we can actually experience, since this is, say, the situation for a typical habitable planet like us, and within our own galaxy. So if there are planets populated even higher, oh gosh, oh, okay. All right, so if there is life which tries to communicate with us in the same conditions, in the same galaxy, on a similar planet, then we would also expect them to communicate in that window. So we transmit it in this window, and we also try to search in the same window. We did that with radio telescopes, and so far that's probably the best we found. It was this famous wow signal, which contains some unexpected kind of combination of characters presented here, indicating the signal, but it was never repeated. And several times observations were made and searches were made towards the same target. We couldn't see it again. So we don't know, was it real or not, or there was something. Or maybe it's just random. So what happens now is that this program started about a few decades, 40, 50 years ago, and 50 years ago, let's say, yeah. And we haven't found anything, and then funding goes up and down. It was funded by government, by private sources, and we are not sure whether we are should continue or not, whether it's worth to spend money or not. But there are some donors, let's say, funders, private funders, like Breakthrough Foundation, that they actually invested $100 million into this program to buy additional time on big radio telescopes and continue this program. So over the next decade, the program will be even broader, even more intense, and maybe we will be more lucky. So that was radio. Now the optical. We can also look for the optical signals. We are creatures which are adapted to the radiation of our star, which has maximum intensity radiation in the range where we see. We call it visual range. We are adapted as live creatures for that. And we produce light in the same range. This is our street light image here, seen from space. And if creatures like us live somewhere else and dependent on the stellar radiation at daytime, they may also produce some street lights or whatever. Maybe it's too naive, but we can search for that anyway. And so far, our telescopes are not big enough to look for such signals. We actually are not sensitive. If there are planets like this, we cannot see them. But what we are looking for is lasers. Lasers are very strong, very powerful radiation in a single frequency. So it's a single color radiation. And we already achieved pretty high radiation power in this using for astronomy. Needs this in Mauna Kea 2 Keck telescopes observing using the laser guide star. It's called that they are projecting these lasers to sky, and then there's reflection from layer in the atmosphere which contains sodium atoms. They scatter that laser, sodium laser back, and then we see it like a print, like an artificial star. And then we can focus on that star very accurately and observe other stars and objects very high resolution. And so such technology may exist also with others. Then there is a use for lasers for optical communication. This is developing now and become more and more advanced. And again, Breakthrough Foundation initiative suggested a project, Starshot, to power with probes to the nearest star with very powerful lasers, which are lots of megawatts, I don't remember the number. So that would be an enormous signal, which in principle other civilizations also can use. And if we look for such monochromatic, single color, very powerful radiations, then we can say that this artificial source of radiation, and it could be also attributed to civilizations. Now, we searched and we didn't find. The other attempt is that we try to communicate. We send messages to the space. And first, this is not really the first, but say very powerful, first powerful transmission was done in 1974 with Arecibo radio telescope, which is about 300 meters in the diameter, and the power of transmission was about 1,000 kilowatts, so 1 megawatt. That was towards the global cluster containing many stars, and unfortunately very far away, 25,000 light years. The signal is still going, expecting reply back in 50,000 years, maybe not very optimistic. But that was not the goal of this transmission. It was just kind of demonstration of capabilities of doing such things. And that was the message sent. It was created by Frank Drake and Carl Sagan within a couple of weeks, which NASA gave them time to create that message. And it's very simple. It contains like numbers 1 to 10 in binary code, everything. Then chemical elements, hydrogen, carbon, nitrogen, oxygen, and phosphorus. Then chemical formulas for sugars and base in our DNA. Then kind of schematic representation of DNA, schematic of humans, size of human and population of humans on the Earth. Solar system scheme with the third planets highlighted, populated by these creatures in red. And the Arecibo telescope itself with the size. So information is simple. If 50,000 will get the response, something like this, then we'll know, okay, there was somebody there. Okay, something more, let's say, practical, yeah? In more recent years, 1999 and 2003, there was 2 cosmic call messages created by Canadian enterprise people. So these are 2 Canadian scientists who were in contact with private enterprise companies which funded this transmission with the 70-meter telescope in Yevpatoria in Crimea. And here, the selection of targets knew a bunch of exoplanets at that time. And so this message, I'll show which one, was sent to 9 nearby stars, so 4 and 5 and 2 calls. And the interesting thing that among those, this target was selected, which is 55 Cancri A, has this planetary system, which is kind of resembles our system. And this is what I compare here, that relative size, of course, doesn't make much sense to the star, but in between stars and between planets, they are comparable. So, and the distance is also scaled here with astronomical units, which is 1 is the distance from Sun to Earth. This is 1 astronomical unit, and all this in logarithmic scale fractions of this unit. So what we see is that in solar system, our planet, Earth, it's a very special place. It's 1 astronomical unit. And it is actually a special place. It's habitable zone. So every star has a distance from it where the planets can sustain liquid water on the surface. And that's what we call habitable zone. So for this star, which is a little dimmer than the Sun, habitable zone will be at the distance approximately where Venus is. So about 0.75 of the astronomical units. And this planet is not Earth-like. It's like a half of the Saturn mass. So we assume, we don't know, but we think that it is similar to Saturn gas giant. But, and it may not have life by itself, but it can have moons, like Saturn has moons. And then on those moons, which can be rocky, like Saturn moons, maybe there is life, because there is a possibility for these moons, rocky moons, have the liquid water on the surface. So that system is very interesting. And it's 40 light years away from the sun. So the message was sent 99. The message will arrive in 2039. Some of us will be around. And if there is somebody else there, maybe they are having better protocol than we have, they send it back. And so in 2000, what it will be, 89, oh, 79, 2079. So some of your grandchildren or children for a couple of years old now, maybe you live so long and maybe you see the message coming back. So this is more practical, of course. Of course, it's very optimistic to think that, okay, there's a planet and there is water, there is life, and there is advanced life, which understand our message and send it back. So there are many, many assumptions, but it's already something. So what is the message? How do we, I mean, I showed you earlier one, it's simple. Here they were more elaborate. So they created a special alphabet. Of course, we cannot expect them to understand our language. If I say you Huva Ilta, I don't know if you know which language I'm speaking. So they created a special alphabet which they call ideograms, ideoglyphs. So it's pictograms or pictoglyphs or ideoglyphs. Yeah. So they are created numbers, words, and different kind of subjects and send the message. So I just kind of play it like this so that you see how it looks. It's like kind of reminds you, some of you who had ever worked with punch tape, yeah? So this is, they send information on the physics, on mathematics, on spectrum of hydrogen, on solar system, on the humans, similar to what was before, DNA, cells, map of our planet, and blah, blah, blah. And in the end, they ask questions. So I could not find translation of these questions. So that's a puzzle again for younger generations. Please learn these questions, because when the answer arrives, you don't know what you asked. So there, in this message, there are all the symbols explained, and you can always decipher what are the questions. So, but they are asked about ET, life, and this symbol here means ET. So everything is like, what is something? What is something? I don't know. So this is complicated. All right, that's a puzzle for us. I mean, for them it will be puzzle. For us it's still, you know. But all right, so another message. Here again, it was 2001. I guess this was very, the new millennium really stimulated people to be creative. Another attempt was to, another message was sent, a teenage message. This was a group of teenagers in Russia who created this message under guidance of a scientist. And this message consisted of 3 parts. First, it was a demonstration of sounding with a Doppler modulation. So when it's like coming and going, so that modulation you need to put in your message so that it attracts attention. So we see kind of, wow, yeah, there is something happening with the signal. So that's attraction. First put the wow in front. And then the information. Information was included also mathematics and physics, but also music. And that music was created with very unusual instrument shown here. It's called theremin. That theremin, if some of you know, some not, it has 2 antennas, and it can be played, can play monochromatic sound more or less without touching it, just by modulation by hands, modulation frequency and amplitude, so volume. So you modulate the tonality and the volume, and then you play music. So I wanted to play for you music which they sent. Just a second. Did we connect here? That's very sad music, yeah? So that is just a demonstration. Tracy, we didn't connect to the sound. We need to connect to the sound. Sound. I will continue. All right, so they send different samples of music from different countries, so in classical and popular and so on. And again, this the targets, what they selected, these are stars similar to what we have, our yellow star, and they we have the connection to the computer, the output. Ah, yeah, it comes from that thing. Okay, good. All right, sorry. Yeah, so they selected targets which are again in the range more or less achievable, 45 to 60 light years. It's a little longer than others, but kind of the same range. So in about 100 years, maybe we can expect some answer. So listen another music, you know, from them. Right. So another way to broadcast. So we broadcast in radio. Another way we send bottle messages. So like previously, people drop bottles into ocean in hope that this letter will be delivered. And now we do the same. And you know, those letters actually reach their adressates even in 100 years. So not exactly those people, but their descendants. And so here we send also such bottle messages with our space missions, and two of them are very well known, as Pioneer 10 and 11, having this golden plate with humans, drawn in scale with the size of this spacecraft, and then showing this scale of hydrogen atom. And then this is like location of the solar system with respect to the center of the galaxy, and these directions indicating pulsars. These are neutron stars which rotate very fast. They have strong magnetic field, and they kind of have this, because of the magnetic field, they are like antennas. They give these pulses towards us, and they look like pulses, although they're just rapidly rotating. And these are objects which will survive for a long time in the galaxy, and they are very bright radio sources. So if somebody in the galaxy ever does astronomy, they should see those pulsars and kind of figure out where we are. Whether it's smart or not, we don't know. Yeah, we did it. So we sent it. We dropped the bottle in the ocean and said, "We're here. Come to see us." Yeah, or whatever. Right. And then here, these are the Voyager messages. They are all again more complete. You see this similar scheme, hydrogen here, and this shows how to play records on this and see images on this on the other side recorded as a, you see this as a golden disc. I don't know. So these are instructions how to play it. So if they're smart enough, they can play, they can recover images and listen to music and see, also hear voices of birds, of animals, and of people speaking there, and so on. And this is already Voyager's already beyond solar system. They already in the interstellar space. It's an achievement for us. That's the furthest ever humanity sent anything artificial made by man, and it's just there. At some point, it gets lost, and we don't know what happens to it. All right. So now, if this SETI, this communication with extraterrestrial intelligent life, is it safe? As I mentioned, the protocol. So we know from our life here on the Earth, life forms can be aggressive to each other, especially those which are stronger to those which are weaker, like shown here. And it's possible that more advanced intelligence in the galaxy can be aggressive to us. So far, that was realized more recently in this century, and there is a agreement that if there is any contact or suspect of the contact detected, then there will be no reply, no immediate reply. So anybody of you listening to the radio and hearing that aliens talking, don't reply. Don't pick up the phone from aliens. The international community will, governments and scientists will come together and decide what to do with it. Try to understand what's the message and then see what's the answer, yeah? So this is the protocol for now. All right, so why do we expect actually that they are talking to us or will talk to us? Because we are talking, yeah? So we are so talkative, we talk to them, we listen to them, we want them to talk. So, and there is this so Václavic axiom, who is, Václavic was a psychotherapist. He actually formulated 5 axioms, and first of them is that one cannot not communicate. So anything we do, we say nothing, like them, sitting like this, we still communicate. We still communicate. And that's the basic for our optimism that we can detect this intelligent or even non-intelligent life somewhere else. That life will communicate. And there is a basis for that, and I will walk you through this, our ideas about it. So we believe that communication is, and we see that, not only believe, but we see it in everyday life, that communication is really essential for survival, propagation, and evolution of life. This is kind of goal of life, to survive, propagate, and evolve, and it cannot do it without communication. It does have to communicate between the species of their own species and between the species between different species as well. And what is communication? What we call communication, commune, you know, this it means like to share. So we have a community, we share, and communication, it means sharing information. So what life does, it shares information, it sends information and receives information. And we say life communicates if there is a live sender and live receiver. So that is live communication. And we, based on that, our anthropomorphic principle that if we communicate, somebody else has to communicate. So on the other hand, we see other forms also communicated here. All right. So what are the communication ingredients? How can we see, like, what is the chain of communication? This is a little bit of theory. I walk you through a little bit theory to show you what actually relevant for our understanding of this communication with aliens. So first of all, we have intent to communicate. So there is a need or intent to communicate. We formulate that intent, like, I want to have a cup of tea. So I was like, okay, so what I'm doing, I formulate how I am asking for a cup of tea. So I formulate the content. And then I encode this, my wish, into words or body language or whatever it is. Yeah, or like just kind of showing by signs if I cannot speak. So I encode, and then I transmit it through sound, through vision, through whatever, electrical shock, say, give me the tea. And the one whom I communicate with receives that signal. He or she has to be able to decode this signal. So that species has to understand, I want a cup of tea, so I better learn how to say that. Or he or she has to understand it. And then that phrase, I'd like to have a cup of tea, okay, you understand words. You have to interpret, what does it mean, cup of tea? It's not only that you understand, okay, cup of tea, but you have to know, okay, cup of tea means hot water, and take this and take this. This is interpretation. So all these steps are necessary when we try to understand. So we go through this quickly, and so intent, from intent to content. What we see in life is that I'm hungry, I have to compete for territory, I have to mate, I say predator. These are all intents. I intend to communicate that information as a life form to other life forms, to support them, to scare them, to compete with them, or offer them food. And then the content is formulated in sentences, like I write it in English, but it can be in any way, as we know with animals. Yeah? Simple. Then encoding and decoding, that is a little more complicated. So in our bodies, we have DNA, which encodes a lot of information. If we transform this into computer language, that comes together that one DNA contains at least 700 megabytes. So that is a lot of information. And our actions in our reactions in many ways of the life forms on the Earth, which have all this kind of DNA, they all define in some sense by this information encoded. Then on the next level, we have a way of encoding information and decoding it is through the stimulus and response. And this happens also on very small scale level between cells and bacteria, single cell organisms, and within the bigger body like us, cells communicate on that level. Simple life forms as well, multicellular respond on that, and we as well. If we stimulate by hot water, then we pull our leg, hand or leg away, so that this is a response. So there are some reflectory responses. These are on a small scale. It's defined by so-called signal molecules. So the molecules on a cell-cell communication, for instance, molecules are produced by cells. They send to other cell, and the cell gets information and react correspondingly. So that is signaling molecules create that information, transmit that information. And in the end, on higher level, like today, we communicate in language. And language is specific. For many years, we thought it's only specific to humans, and that's what distinguishes us from animals. We find more and more evidences of languages similar to ours in other animals. And I will show you examples here. It also exists in insects. We found out that they communicate also in kind of language. It's not auditory or visual in a way how visual as well, but not auditory maybe in a sense like we do it. But if we include it as well, auditory, but also lots of chemicals and so on. So very similar basically to humans. Humans also communicate at chemical level, yeah, and other ways. All right. So we must be sure that advanced life, more advanced than ours, will use a complex language to communicate. If we have pets, we talk to them in our language, and they talk to us in their language, and we kind of don't understand often what they say, but they understand our language. So there's always like this dominance. Dominant species teaches the language to the less advanced species. All right. So language is a complex system. It consists of many different aspects. So here, I want to emphasize this because I want to compare human language with the animal language here. That for language, what is specific, it consists of signs. So this could be letters or sounds or chemicals which animals produce or we produce. And these signs are associated with meanings. And then, as I explained you, that meaning has to also be further interpreted. This is a perfect illustration of that. That you have a sign, there is a meaning, there is a bad, but you know what is bad, but you still have to know what is bad in that situation. And that's decoding. So that you still have to interpret that bad, even though you know it's bad. Yeah. So and here, just.
Dạ có đi cô
nói đi Tình.
say cheese Chicago I see you
Nói đi Tình, nói tại sao hồi nãy Tình vô phòng làm gì?
Ôi nãy đừng vô phòng nhìn làm gì?
All right, so this boy was speaking language. Do you know which one? That's right. Very well. Yes, Vietnamese. Vietnamese, yes. And why I bring Vietnamese here? Because Vietnamese language is very tonal. So if you change the tonality of your words, they change meaning. And that is complicated to learn it because of this, but that illustrates that when we hear language of animals and they change tonality, it's not just decoration, it can contain the meaning, because that's what happens in a human language. Okay. All right, so what are the language characteristics? This is a little complicated, but it's illustrative. That first one is that when we connect an object, like a hand, with a symbol or sign, like here written in English, Finnish, and Russian, that you cannot predict. If you don't know Finnish, you cannot say how it will be in Finnish in advance. So that connection is not predictable. Whatever it is in Vietnamese, I cannot predict. I don't speak Vietnamese. So that's called arbitrariness. So this connection is unpredictable. Then you use elements of the language to create like letters, these simple elements, single elements of the language, like letters we have, to build words, and then from words to build sentences. So you increase level of complexity. That's called duality. You create layers of complexity. Then we are capable of imagining and operating with objects which don't exist. Dinosaurs, we never seen them. However, we somehow recreated them based on bones and some other things. We decided that they look like that. Yeah. And if we think about future, we draw futuristic pictures of cities. We never seen them, but we're capable of producing objects in our mind, abstract objects which have names. So we can capable of producing names for that. That's called displacement. This is very interesting as well. That we are capable of creating new meanings using the same elements. So this element ha, and say ha, whatever it means in whatever language, if you say it 3 times, it will be ha ha ha. So it has a completely different meaning from what it was before. So that is also productivity, that it can be endless amount of such combinations. If I say 3 times means something, and if I say 2 times, it's something different, yeah? So that is a sign of the language. So these characteristics indicate that if these elements exist in the signal system, then it must be a language. So I bring you to the animals. So I want to show you that actually animals have that ability. And not every scientist agree with that. So, but there are a growing number of scientists which support that research and agree with this interpretation. And you must remember, everything what we know, it's interpretation. Again, like I showed you, in the end, there is interpretation. All knowledge from our measurements, from our observations, everything we interpret. So it may not be reality, it's our interpretation. So that's why there are always debates, scientific debates. Some say, I interpret this way, and others say, I interpret this way. Anyway, so these are the cute animals, prairie dogs, and they make sounds like this, which may not be very intelligent sound, something like this. But there was a study, especially by Kon Slobodchikov, who had a group of students and employees there to investigate these interesting creatures. And what they found is that they have different alarm signs for different predators, including humans. And they were playing the role of humans there, of course. And what for me was very impressive to learn is that they changed appearance of humans, and the signals changed. And they did it many times, and they realized that animals attach adjectives to humans. Not only, so they have nouns, they have verbs, and have adjectives. They can indicate direction, they can indicate location and distances. So if there is the predator coming, I don't know, from the top and fast, this will be in the message. So hawk for them. If it's a coyote going slow nearby, it will be different signal. So there is not so much danger. It's walking somewhere at the distance. So for humans was done, it was absolutely stunning for me to learn is that change colors of t-shirts. So there was the human going in red t-shirt and blue t-shirt, yellow t-shirt, and the signal changed. So they did realize the colors. They identified the colors. Then other thing is that they created a new signal for the object they never seen before. So the researchers created objects, something like, I don't know, circle and square, and it was moving and, you know, like kind of representing some unknown creature for them. And they made a sound for them. They made a signal for them. And if this object again appeared, the signal was the same. So they were learning. So they were capable of learning, creating, and all elements here absolutely fitting into their language description I gave you before, which is based on human language. So there is not much difference there. And interesting thing how we learn that. We change the context of the reality around these animals, and then we learn how signals change. And then another option is that they record these signals and play back to the animals and check if reaction will be the same as they recorded in the situation as they recorded. And it is. It's actually reproducible. And if they use these signals and like there are some combination of them and they shuffle them randomly and combine them in the order the animals never heard, the animals don't react. So for them, it's abracadabra. They don't understand it, even though it's their own voices. There is no meaning. The meaning was absent. So it's not just signals and stimulus, it's a meaning what they transmit. All right, this is the next one, the birds. This is also... Okay, I'll do that. So is bird, and the classical maybe is chickadee. You probably, many of you know this bird. Let's try to play the sound of it. Again, where is this? Well, this is again very simple sound. It becomes more complex further, like here. It becomes just a second. Yeah, this. Well, it's more complex coming later on. But so what was found by observing these birds in different contexts? Again, it was found that they have 4 syllables, A, B, C, D, they call them. And these different sounds, different whistles, and they combine in different ways, depending on the context. And I don't give many examples here, but maybe believe me that I read this in some articles, that they say that grammar of this combination is complexity of that grammar is similar to the human language. And if you look at these combinations, what they say, the sound exists, A, B, C, C, and so on. Again, like in case of prairie dogs, random combinations don't work. It's a specific combination. Combinations have meanings. And what is interesting also, that these birds are, some of them, bilingual. So the species which are related, they speak slightly different languages. So they have different songs. But if they live nearby and they have to communicate as neighbors while marking their territory, they actually speak both languages, because you better learn language of your neighbor to avoid the conflicts. And some birds were found to be bilingual. So now, if you're not convinced whether it is complex enough to call it language, I'll give you the example. So this is something meaningful And I asked this young lady to help me to read this. All right, so let's, I'll give you my microphone, like this.
Yeah. Coco, cockoo, cocoon, coco, coco.
So, did you get anything out of this? What do you think? Do you think this is the bird song, or this is animal language or human language? No? Okay, thank you. So I can read it to you, and then you tell me whether it's human or not. So, coca, 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 con, coca, 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 and coca, coca. So how does it sound to you? Do you think it's a language, a human language? Yes. Which one? No, that's not programming language. This is Finnish language. So, and this is meaningful dialogue. So these are the, you see there is core, let's call it A, yeah? There is a maybe single core or cock, I don't know, you can call it B. So there is like 3 N, there is on, yeah? On, core, and a double K. So three combinations. And you repeat them A, B, C, D, 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 C, I don't know what, and you have a meaningful conversation. So this conversation about making a bonfire. So someone asks a boy called Coca, this is his name, Coca, then gather together in entire bonfire. So that is there, and then it's a conversation. Oh, do you want really me to do the whole bonfire? Yeah, you do. Oh no, this is so terrible, blah, blah, blah. So this is the conversation. And you know, I think this, for instance, this is not less complicated than this. So this is, I think this is a very interesting example. Now, humpback whales, many of you know they sing, yeah? Some of them maybe heard it in life, I didn't. So those singing is very interesting. It's only males who sing them. We can listen to the song again. I have a recording. Maybe some of you didn't. So these songs can last for half an hour. We don't listen everything, yeah? And if you analyze the sounds, then it was found that there are units which can be seen as syllables. Then from these units, they create phrases, which can be seen as words, actually. It's a little misleading here. Then they create from words sentences, which called themes. And from themes, they create songs. So there is this structure, which we would call language. And interesting thing that one third of these themes, they rhyme. They end with the same sound. So, and then the question is like, why do they do that? And then you can actually understand in the sense that if you sing something for 30 minutes, you have to remember it, yeah? So that rhyming probably helps them to remember what they're actually singing, because this song can be repeated many, many times. This is how we teach children also singing and talking by learning the rhymes. Do you know many rhymes? Some of them, yeah. All right. So the problem here is that we understand that it's what the are similar to the language or poetry even what we have, but we don't understand it. We don't understand it because we cannot observe them continuously in different contexts, like we can observe birds or prairie dogs, even make experiments with them. They are in a vast ocean and gone, and we don't know what they're doing. And that means actually that that presence of the context for understanding is very important. That's what I showed you in 3 examples for animals. Context is extremely important for interpretation. We can decipher in this ABCD and maybe even see that actions is this ABC sounds this way and the other BCD is this way, but interpretation very much relies on the presence of the context. And then we talk about communication with aliens. It's maybe the situation like with whales, that we hear the sounds, we realize or we hear the signal, we detect the signal, we realize there is conversation, but may not understand what's going on, yeah? What is about. Now, that was about meaning. Now, how we transmit and receive this information. What is happening on the examples I show here, it's a visual, acoustic, and kinesthetic, which touching and sniffing and drumming here, and even electrical signals from this fish, is that life to communicate uses physical laws of the environment, physical properties of the environment. In many cases, these are electromagnetic forces, electromagnetic interactions, which are used because these are on the basis of molecules and atoms, or direct interaction with the electromagnetic waves in sense of the light and radiation, or acoustic, for instance, using, so I abbreviated here as the pressure waves. So if we shake something or drum on something, earthquakes, for instance, create as a pressure waves. Or the sound I create now, these are pressure waves. We use the propagation of these waves in the matter. So electromagnetic waves, they can propagate in the vacuum, and the pressure waves, of course, require some matter to propagate. So for communication with aliens, again, over the vast space in the universe, we do hope they communicate with us in electromagnetic waves, and that's where we look for radio and optical and infrared and so on. And we also transmit electromagnetic waves to them. So this is like a first choice. We probably at this point we don't know anything better for communication through the universe. Now interpretation, as I said, it will be difficult. So in the case of the stimulus or DNA encoded information, stimulus response information, the reaction or interpretation is pretty deterministic, although it may have some noise. So here's examples what cell does if it receives the signal. So cell has continue living, survive, can divide, it can differentiate into some other cell or die. So these are all signaling molecules which come into the cell and give the information. The reaction is well determined by information written within cell and interpretation system which cell has. When we talk about languages, which is choice-based and maybe probabilistic in a sense, because it allows for a range of interpretation, this cartoon shows that one speaking, one listening, not necessarily the same. So this mass here, it's that range of interpretation. Hearing sound, you hear me, maybe you don't hear what I want to say, you hear something you want to hear. So that is a complication, yeah, in communication. Absolutely, yes. And it individual based, yes. Multiple interpretation. Each of you get different information from what I'm saying. Absolutely. All right, I do not repeat that, but we can maybe we can put this in the discussion later. Okay, sorry. Now, there's a very important issue with timing. Experiments show that if we speed up whale songs, it sounds like a human song, and if we speed up human song and further speed up whale song, they sound like bird songs. And if we slow down backward, they also match in appearance, of course. And that somehow maybe creates some hint that could be related to the speed of processing of the information by the animals. Maybe small animals have to do it faster, and big animals have to do it slower. Right. So that is very important again. And alien life may communicate already with us, but on a different time scale, not the one we expect. That wow signal I showed you was like several symbols in a row. Maybe they communicate like one symbol one a year, you know, we don't know. So that is important issue. What is the timing of communication? Of course, that is defined by the urgency or by the intent of communication. If it is alarming on predators, it will be fast. If it's just a leisurely song, it can be very long, yeah, and very slow. All right, now interspecies communications. That what before was only species within the same class of species. Now interspecies. This is how I figured out. So there is a prey-predator, of course, communication and backward, yeah? So this one goes here and this one, makes some sound. Then there is a pet master. I don't know, my English maybe not so perfect, but I call it this. With pet owner also one can say. It is usually friendship. And curiosity. These different species, they're just curious what's going on. So they ask, they approach each other and being friendly. Right. Now we succeeded to teach a sign language to great apes like chimpanzee and gorillas. And here is a movie which is interesting. All right, so that speech, maybe not created by her, but reported she knows about 1,000 signs. So she uses 1,000 signs to communicate with her friend, her scientist, who lives with her already like 40 years. So she's now 44 years old, this gorilla, Coca, her name. And she understands spoken English. She understands about 2,000 words, like maybe what I understand, I don't know. And because that scientist who lives with her, she, when she was teaching and communicating with her by sign language, she continues to speak in English. So and you who have pets also, you know that pets understand even if we say nothing, I mean do nothing and we just talk, they understand. We give them information. Then that is very, again, like I said, coming to this, it's another kind of advertisement. Okay, so that is again. I mean, there is a controversy there that they can repeat the signs of their instructors. Yeah. So the speech what they make maybe not so immaculate as it demonstrated, but they do use the signs and they communicate about feelings, about their friendship, attachment to the people, and so on. About they can communicate about feelings and needs. And this is demonstrating that we actually do succeed in teaching other species our own language, and which is interesting. So now I go to alien communication. This is the last part. So finally, what we learned from animal life here and different forms of life, how it can be projected to space. So this is the scenario number 1. What if we are at such a called ontological limit of understanding other life forms, like we are so underdeveloped that we cannot see and hear those signals from other civilizations which are far beyond in their development what we are. So this citation from Star Trek that they refer to extraterrestrials, Organians, which are so advanced above the humanity as much as humanity advanced above the amoeba. So we could be those amoebas in that vast universe as a civilization, very primitive yet, and we're looking for signals of the same. And no way, those don't talk so much, you know, or they short distance talking, and a long distance advanced civilizations talking. And we don't just understand. We have no capability to even perceive those signals. So we search for signals, but we cannot even perceive them. Oh, sorry. Then scenario 2 is that there could be intentional signals with the intention. We again have to search for intention of socializing, of colonizing, and propagating their own life. And they would send electromagnetic signals, most probably, according to our current knowledge, maybe something else, again, we don't know. And that's what we do with SETI. We try to search for these signals. And 2 famous examples, this contact, when they received these instructions to build a machine, and that was a very impressive contact information. Or 2001 Space Odyssey, when they send probes, self-replicating probes into space to propagate their own way of living, propagate their own civilization, don't care about anybody else. And these intentional signals we look for, and as I mentioned, there could be problems with that. I'm sorry. Then scenario 3 is that there must be also unintentional signals. It's like life cannot not communicate. So there must be unintentional signals. We know that if we stand like this, it means that I'm not happy or whatever. And what we figure out that life has to have some heat effect on the environment. We have that as well. We have a temperature. Everything has temperature in the universe. Everything is of certain temperature. And we have temperature of, I don't know how many Fahrenheit, but I know 36 Celsius, 37 Celsius. And we generate heat when we do some activities. And we generate heat when we run our computers. We generate heat when we run our air conditioners and factories and everything else. And that heat is deposited into the environment. And we see that heat in cities, already in our cities. The cities are much hotter than the natural environment. And that heat is producing additional infrared radiation. And that infrared radiation will be just very comparable to the temperature, ambient temperature of the planet, but a little higher, a few degrees higher. And we can search for such signals. And here at IFA Maui, we develop a project based using the Colossus telescope to build this in the future big telescope to detect such infrared signals due to advanced civilizations. And this is our webpage. You can look and sign up for the information about this project. But And we will be capable of looking for civilizations similar to us, but more advanced civilizations, again, there is a hypothesis that they would be able to use energy, entire energy from the star, radiated by the star. And then the way how to do that, it was suggested by Dyson, that they would build kind of sphere around the star to capture a whole energy from this whole energy radiated by star and live inside the surface, inside the sphere. So the planet would be like inside out, or out inside, I don't know. And so the civilization would live inside that surface. And this is like from Star Trek movie, they found one. So in the movie they found one in one of the episodes. And there are scientists who search for the signals of Dyson spheres. They would have also, again, a temperature very close to comfortable temperature for life to exist, with some infrared excess, but they were not found yet. So there is a search for them, but they're not found yet. But Colossus telescope will search for civilizations similar to ours, maybe a little more advanced, not yet with Dyson sphere. So now we come to the end, and the question is that we know so much about communications, we try so much, and why there is silence? So this is like a little summary of what I was trying to tell you, is that it's possible signals exist. It's possible that universe is just like a radio talking, and many channels are there, but we don't hear, we're deaf. We don't understand that language, we don't hear it. So why cannot we hear it? We could be amoebas, yeah? We can be just beyond that ontological limit to understand it. Or we'll look at wrong time scales. Instead of this, wow, we have to see wow, or wow, like this, yeah? So, and maybe our language concept, what we learn from ourselves, what we actually exist in animals and insects, DNA, we have the same base. There is a gene vertebrates responsible for language recently. We similar. We are the same fruits of the same tree. So maybe our concept of language is so human kind of focused, yeah, and limited that language of aliens is completely different. Or maybe universe is so vast and the signals, they didn't reach us yet. Maybe we're too far from them. On the other hand, signals may not exist at all, and that's, for instance, nobody's there. We are alone. This is hard to imagine, but not excluded. Yeah. So the civilization, they appear and disappear. We've seen there were several civilizations before us. They vanish because there are some other barbarians coming and build their own civilizations. And for instance, other option is there is no intent to communicate. Maybe they recognize that communicating with other civilizations is dangerous because of diseases or colonization, uninvited guests, and so on. Yeah, so that could be a reason for them not to communicate. There is no need. There is no intent. Or another hypothesis, like called zoo hypothesis, what if they are seeing us, but they don't communicate on purpose? Again, not to invite us for something, or not to disturb our evolution. Maybe that's ethical responsibility for other civilizations, more advanced, to give chance for others less advanced to develop the way they are. So that could be an ethics, kind of interstellar ethics. And with this, I want to finish, and we can do questions. Thank you very much. Yes, maybe we put light or not. I don't know. Sure? So. So the question is that how much infrared radiation we emit as humans, yeah? So that is 15 terawatts, I think. Like this is our total radiation, and the number itself may be not so interesting. But what is interesting is to compare to the amount of energy which we receive from the sun, for instance. Yeah. So that is about 4/100%. So how to say this? 0.04% from of the energy we receive from the sun. So, and if you compare this, for instance, with the photosynthetic life, like plants, they actually process 5 times more energy than we actually produce or recycle or whatever we do. So that is an interesting number. Okay, the question is that if we can use spacecraft, Voyager and Pioneer, who are now further away. The pulsars, okay. Right, whether we can use pulsars to communicate with others, yeah? That's the question. Well, we have to influence them somehow. So that is the problem. That's the problem. So how can we influence them? We can maybe reflect somehow, like it's too weak for us. Signal is too weak to reflect it and send back, for instance. We cannot influence that radiation. We can detect it, but we cannot influence it, like modulate it also. So there are some ideas that we can somehow modulate solar radiation, whatever. You know, some crazy ideas that we use our nearby star to modify radiation somehow of that and communicate with the sun. So because that, again, stellar light seen much further away. Yes. The question is that we broadcasted analog TV, but if we would do digital, would we still broadcast, yeah, to the space? Well, there is still some, depends how if you use cables, then it's only local, yeah, the emission. If you use wireless, then you have some still broadcasting, yeah? So that is, this is the answer, yeah? So depends how you broadcast your digital information. You can do optical also, that's what optical lasers are used as well for communication. So digital information can go through radiation as well. Yes? There are people talking about that, definitely, but I haven't seen, so I'm not. So it's like the science is based on repeated experiment. So if you see something once, like this wow signal, you cannot say, oh, I detected something. You have to say it 3 times at least, or 5 times. Same with these vehicles. If there are 5 people at different times in the same vehicle, in the same place, or whatever, in same occasions, then we start to investigate that phenomenon, yes. All right, some more questions? All right, yes? Right. So this is the question is that whether we can use mathematics as a universal language to communicate, yeah? Indeed, this happens, and there is a research field that scientists do develop language for universal language of communication based on mathematics and physics, also physics laws, but mathematics mainly. And because in principle, the pre-assumption again, if somebody else will be detecting our signals, they would be able to build some kind of antenna, and to build antenna you need physics and mathematics. So we try to present it in a simple way so that can be recognized, and that's why the messages we send, they are starting from mathematics and then develop further into other information. Too bad. So the question is that if we blow us off, then in 100 years there will be nobody to receive the message. So then maybe that happened in the past. No, it could be. We're here on the earth as humans 100,000 years, and maybe there were messages before. We missed them. Possible. Yes? Next question. It's deep. So the question is that, all right, the question is, what's the structure of the language in terms of language elements, like nouns, verbs, and adjectives, yeah? That's the question. Well, I must tell all languages are different. So we know Germans, they put everything in the end. Japanese do the same. So the meaning is like you have to listen until the end of the sentence to understand it, yeah? In Russian, for instance, I speak Russian, you can put words in different way as you wish, and the meaning changing. And what you use is you use punctuation or intonations to say whether it is, the order can be the same, meaning will change with intonations. In what? Prairie dogs, yeah. So question is for prairie dogs. I actually cannot say that, how they combine that, sorry. That's, I haven't seen the sonograms in this way. I read the book and I got the information, but sonograms I didn't find. Yeah. So, but for instance, what we learned from apes, how they use the language. They use it at the level of small children. So they basically achieve understanding. So if you say tea, Coco tea, I don't know, she's Coco, yeah? So you say, by the way, also Coco, yeah? So you say Coco tea, so whatever. You don't say want, yeah? I want Coco wants tea. You don't need use the proper grammar to actually communicate. So the proper grammar does not exist in the spoken language, even in our educated conversation. So that is true for animals. Although grammar in the sense of syntax exists, that combination of words, they exist, yeah. All right? I think first we have to decipher. So there will be an effort to understand that signal, to confirm maybe somehow whether, if this will be like, you've seen the movie Contact, yeah? If it continues information flow, no doubt that is something you got a real message, yeah? Then there is an effort to decipher it. So there will be time to take it. Then interpret it, like in a way that, what does it mean? It's aggression, alarm, or friendly hello, or something like this. This will take time. And I cannot say what will be the final decision, do we answer or not, depend on this content, how we interpret it, but maybe there will be some caution that maybe not immediately. I don't know. I don't know what to say. It's hard to decide. I'm not deciding for everybody, but some people will be more. Right. I mean, sure. Yeah. It's like when I say if we wait 80 years for response, it probably also for a couple of years for them to understand it. So, or maybe if they decide not to respond, that's as well, you know. Or that is. Yes. So the question is that if there is a scientific reasons to understand and believe the possibility that there is a communication on a level we don't understand even between humans, like you said, between child and the mother being in different parts of the world but feeling for each other that something happened to one of them. And so my answer here is that indeed, as also you mentioned, that indeed it's not, we don't claim that we understand everything. So we're, of course, the world is, as I said, is our interpretation. So the world may be somewhat different from what we think about it and what this model tells us. So I don't close the door for the opportunity that there is something else. But in order to make that, in order to validate that, so you say metaphysical, that somehow a term implies that something unexplained, yeah, or something not scientifically proven yet, yeah. So in order to, from metaphysics move to physics, let's say, it has to be measurable. So when we learn how to measure people responses in such situation, whether they communicate or not, and which level, then, and if this is repeatable and reproducible measurements, then we say, yes, we found something in addition to what we knew before. And then that metaphysics become physics. So it was like centuries ago, electricity and magnetism was metaphysics, and then it became physics. So maybe in some other ways we can achieve that with other ways of communications. Example, for instance, for whales, that I didn't mention, that the songs that whales sing, they were studied in different breeding regions around Australia, around here in Hawaii and Pacific, and different places, Atlantics. They sing different songs at a given time. But next year, the group which was feeding near Australia will be singing song which was sung maybe here in Hawaii. So somehow they do, even though we think that there is no way that waves, sound waves will go so far, they somehow find a way to transmit those songs to each other. So they learn it, and we have to still understand how this is possible. So. Absolutely. So the question is that if whales are isolated from each other, if they can still communicate, they do learn from each other, the same way as our children learn from us. And if they are isolated, we know that children were lost in the forest and they don't speak human language, they start to speak animal language or forest language. Yeah. Okay.